Hello, viewers. I hope you are doing good and welcome to the channel of Ahid Byte. Today, we are going to solve another problem of a lead code, which is valid parentheses. And it's a little bit different problem than the previous problems we have done so far. So in this problem, what we are going to learn is we need to do the stack implementation, and we also think about this problem will give us the ability to think how code editors working behind the scene, like we are doing the coding stuff every day and we are opening and closing the brackets. So this problem just give us a little bit sense that how this all stuff has been done for us in the code editors, and it's also pattern matching related question. So without any further delay, let's deep dive into the presentation and let's see how it's work. We are in our presentation and let's understand the problem requirement and break it down into a small step and understand it. So our problem is given a string S containing just the characters of these type of brackets. Determine if the input string is valid. So what is our objective here? We need to check and a string pair it properly, means we need to match both cases of starting bracket and the ending bracket in the correct order. This is our objective. For example, there are some inputs and cases that we need to apply. If you can see in this case of input, there are brackets, open bracket and close bracket, and these are in consecutive order, means it is properly working, means properly available for us. There is no differentiate and no other bracket comes in. So in this case, we just return true. On the other hand, if we can see this input where there is an open parenthesis and the square bracket, which is distinguished, both are the separate, therefore we will return the false. Let's consider some of the edge cases that we need to take care in this problem. So first of all, the bracket must be matched. For example, if we open the square bracket, the closing bracket must be the square of the same type, means this is the first case. Then we need to care about the correct order. For instance, like we have open parentheses and we directly close the parenthesis before the next bracket is comes in. For example, this is the curly bracket. It comes after the parenthesis, so parenthesis must be closed and then we will consider the curly braces. Similarly, we need to keep balance between opening and closing brackets. Means there is no extra brackets between this all scenario. Let's now little bit talk about the approach. What approaches we will use in it? It is simple, means push and pop. Like we need to, when we have open bracket match, so we can something to push in the stack, and similarly we can pop it out if the closing bracket we can match it similarly. Then for that purpose, we need some kind of rules that first we define all the rules of opening and closing brackets. And then on based of that rules, what we need to do is we need to process all the sequence of how this on every element, how the operation will be performed. Let's see it more visually by breaking it down into each character, because a string is a sequence of character for us, so we can treat it as on every index like a simple array we can do. So this is the character from 0 to 5, like all the bracketing that comes after in the input. Then we have a stack which is initially empty because we need to keep track of push and pop operation that can perform inside this stack. Then what we need to do is, like for example, on the index 0 we have a character of opening braces. So first we need to directly push it into the stack. So how our stack will look like after the first operation, we have added the opening parenthesis. Now in the next run, for example at the index of 1, we need to have another character. Now you can think about it like, for example, the starting opening bracket and just after the closing bracket comes in. So the pattern is little bit matching because the opening bracket is the similar as the closing bracket. So in this case we need to pop it out from the stack because our scenario is matched. Now for the next index, what we need to do is we need to check like opening bracket of the square bracket, and we need to push it. Same we need to put into the stack. Our stack will be look like this, and then we need to pop it because it's match. For the next scenario, because all the bracket are similar, what we need to do is we need to push and pop. Here we can see that at the index 5, which when it will be popped, so our stack will be look like empty, and we return all the program as true. This is because everything, the opening bracket and the closing brackets were same and in the correct order, and we now return as a true because our cases are fulfilled and everything is in the correct order. Let's say for now and see how we can write the pseudocode for this program. First of all, in step 1, we need to create an empty stack. That stack will be keep tracking of our brackets when we perform the push and the pop operation. Then we need to consider some kind of matching rules for our brackets. These are like parentheses and square bracket and curly brackets. So we can match with the closing bracket with the opening, closing with the opening of the square, closing and opening with the curly. Then in the step 2, we can loop through each character one step at a time. We can find the opening bracket first inside the string characters, and we can push it into the stack. For example, whatever the opening bracket will be, we can place into our stack. We can keep continue with the step number 2, and now it's time to check the closing brackets actions. Here we have some extra checks and extra cases that we discussed in slide number 2. So we need to check if the stack is empty or not. For example, if we found any empty stack and there is no opening and closing bracket match, then it's time to stop and we return it like false. There is nothing to found, means this case will be false. In the next, for example, if we have a stack which is not empty, it means there is something. So what that something is, we need to keep track of that top items which is inside the stack, and then we match it with our bracket. If it is matching the rule according to our situation, whatever we give it to it, so we need to pop it out. So these are the two scenarios if the stack is empty or if the stack is not empty. Then we also need to check its correct order. For example, we need an open bracket and the closing bracket. Either we started some other type of bracket or not. Means we need to check it. So it must be in the correct order. First sequence will be the parentheses, and then will be the curly braces, and at the last will be the square brackets. Means it will be the correct order. This is the requirement of our problem. In the last, if we found everything, means all the character we have sequenced through, then we need to check the stack is empty. It means everything is correct. We need to return valid. Otherwise, we are not valid. We return the false as our program, and program will be ended. Okay, I am on my code editor, and let's start implementing the pseudocode that we have written down. So first step was to make the stack. like empty stack, I can say stack is this is the array and we can make it empty. Now, in the next step, we need to define some rule that can keep track of our brackets. I can say matching brackets equals to I can place dictionary here because it will give me the key and value pairs where I can define the starting brackets with the ending brackets or similar pattern. So first I can say in the reverse order I will make the closing bracket match with the opening bracket. This is my opening bracket. Next, what should I do? I will create a rule for my closing square bracket and opening square bracket. So here I can do this. And in the last, I should do is the closing curly bracket and the opening curly bracket. These are my rules that I define. Now I will loop through the string and check it out each character one at a time and perform the operation of empty, not empty and a sequence of character. Let's say I can say for character in means char in s. S is our string. Here I can check the opening uh, part first. If character in. So I will check all the open cases first. The parentheses, the square bracket and the curly bracket. If this is true, then I need to put into the stack. So I can use the stack built-in function of Python called append and I will place the character inside it. In the next, if this is not the case, then what will happen? In L, if I can say character in the matching bracket means matching. In this case, first we need to now in this part we need to check the character inside the matching brackets. If this is happen, what should we do is we need to check the stack is empty or not and other cases that we are not to define. So I can say if not stack or stack last character. Let me explain this to you. What will not operator is doing in Python when we define it, it's operator, it returns true on the falsy values. Like if this is stack is not empty, then it will return true. And we also need to consider the rule of the last character that we need to consider. Therefore, we go at the end of the character. For example, this is the end of the character, so it will target to this. Does not equal to matching character. What inside the matching brackets? The character that we need to target. So I will target that care again. In this case, I will return false. And at the end, I will pop the character that inside this stack. So I can say stack dot pop. It's a built-in function again, which can give us the pop out, the remove the value inside the stack. So at the end, I will just simple return not stack. It means that everything is correct. Now a stack is empty, so it will return the true. Uh, I think this is the end of this program. Let's run it once to check what are the behavior of our program. It's wrong cases. What mistake I have done so far? Just third character is correct, but second is not. Let's start reading stack. This is the opening bracket, this is the closing bracket, opening bracket, close bracket, open and close parenthesis. Now I can check and and else if the character matching brackets, if stack, if not stack or not matching characters, return false. I think this will be happen here. Let's run it once again. STSCK and run. Let's say what it is given to us. Again, we have some kind of missing. So what it will be on getting it where it's making the mistake and say pop. The pop will be inside the else if, not in the if. Oh, yes, it was the problem because we need to check the in the else if condition, the pop will be happening, not in the if condition because this is the if, this is opening if, and we were defining stack here. So it will target related to this if statement. So this was the problem. Now we need to place it in the else if condition because there is something in the stack, so we need to pop it out. So this was the problem, and all the cases here are correct. Now let's review it once again and see. First, we define the empty stack, and then we define the rules for where we need to matching the cases, and then we loop through each and every character. If the characters are open, then we need to add into the stack. Otherwise, we need to check the empty analyze like the stack empty stack, which will consider as just one operation. So it will take O of one. Similarly, the matching brackets will also take O of one, and inside the loop which will be taking O of n time because it will be going through each character step by step and then performing the operation. So it will take the n time. It is based on the input size. Then each cases inside the loop will take just O of one operation. Inside the loop, it will all consider as O of one operation because either it is checking or appending or comparing. Every step will take O of one. So according to the rule of the big O, we does not care about the thing that is not given the multiple growth into our algorithm. So we can eliminate it like O of one wherever it is, like initialize it O of one. Then processing will take O of one multiplied by O of n multiplied by O of n. So we can consider it as O of n, and the final check will be O of one. So if we ignore all the things, this total time means we can ignore all the O of one, and we if we simplified it all, so we come up with the simplified version of O of n. So this is our big O notation. In the worst case scenario, it will be performed as O of n time. Okay, that was it for this problem. We understand it step by step. First, we check the break it down the problem and understanding it little visually, and then we move to the code editor and write it down all the code step by step and match all the cases that was required in this problem. and at the end we analyze each case of our algorithm, and we come up with the solution of O of n, which is best case solution for this problem. If you really enjoy it, then please like and subscribe the channel. Until the next video, my name is Ahir and this was LeetCode 20.